Dear students, thanks to all for watching my lecture. Today I am talking about a special part of Newtonian mechanics, moment of inertia, first paper, chapter 4. Today's lecture will be slightly different than other lecture. Okay, today I try to solve the moment of inertia in case of a triangle. This is really very important part. Okay, in our previous lecture we learned how to find out moment of inertia for different shape of the object. Already we complete uniform rod, already we complete circular discs, already we complete cylinder, already we complete rings, and already we complete solid sphere. Okay, now today I will discuss about the moment of inertia in case of the triangle. It is really very important part. Now I am try to draw at first the triangle. Suppose this is the rotational axis, this is the rotational axis, x prime is a rotational axis. Okay, suppose this is the triangle, this is the triangle, this is the triangle. Okay, and this triangle I try to give you some example information here. X prime is a rotational axis, and here we see a triangle. My dear students, this is the triangle. This is the rotational axis, and this is the triangle. This is the triangle, equilateral triangle. Okay, in case of the equilateral triangle, this is triangle. The name of the triangle is A B C, and x prime is a rotational axis, and this is the direction of the rotation. Suppose this is the triangle. If this triangle rotate around this axis by this way, okay, our first duty is to give you some information about the triangle. Suppose the length of the triangle, triangle is, this is the length, this is the length of the triangle. Okay, and this is the height of the triangle. This is the height. Height is s. S means height. My dear students, here I draw a triangle. The length of the triangle is L. Length is L. This is means base, and this is the height. We can write here, this is the base of the triangle. Base. This is the base, and this is the height of the triangle. Now our duty is to find out the moment of inertia of this triangle in case of, if this triangle rotate around x prime axis, this is the direction of the rotation. Okay, our first duty is to measure moment of inertia. We know our formula is I is equal to mr square. Okay, this is our formula. At first, if we apply this formula here, then we need point mass and perpendicular distance between the point mass and rotational axis. My dear student, now our duty is to take a very small part of the triangle. Suppose this is the very small cross section, this is very slight very small cross section here. Okay, this is the very small cross section. The length of this cross section is dx. Okay, and suppose this is the length of the small section, very small length, and dx is the width of the length, and this is the perpendicular distance from the rotational axis is x. Okay, now our first duty is to find out the mass of this very small, that means very sliced part of this triangle. If we find out the mass of this very slight part of the triangle, then it is very easy for us to develop the equation of moment of inertia. Okay, suppose the area of the, we know the area of the triangle is area of the triangle is, we know, half into base into height. Okay, as the base of the triangle is L and height is S. Okay, so here we get the area of the triangle. Suppose the mass of the triangle is M. M is the mass of the triangle. My dear student, now our first duty is to measure the very small mass, that means the very small slide, a small section whose width is dx. For dx section, at first we try to find out mass. Suppose the mass of this slide section is dm. How can we find the mass of this slide section? Suppose if the area is half LS, half LS. For this whole area, suppose the total area of the triangle is half LS, so the total mass of this area will be M. Okay, tahole try to understand, in case of 1 unit area, total mass will be M divided half LS. For per unit area, the total area of the triangle is half LS, the total mass will be M, and for per unit area, the total mass will be M divided this. This is the unitary method. Okay, now our duty is to find out the area of this very small or slight section. You just try to understand, as much as the width of this small section dx will be very small, then this small section should look like as a rectangle. Okay, all of we know the area of the rectangle is, the area of this section will be length into height. The length of this small section is L, and width is, height means width is dx. Okay, try to understand actually what is happened here. If the value of dx more small, then this small section should look like is a rectangle. Because of that reason, we can write here the area of this small section is atho. Now our duty is, if we find out the mass of this area, then we help this equation. As we know here, for per unit area, the total mass of the object will be this, and in case of L dx, total mass will be M divided half LS into L dx. So we can write this small area mass denoted by m. So we can write dm is equal to, we solve this section, 2m divided L is L dx. Okay. Now our duty is to find out the value of the ratio L divided S. How we can find? Now here we can see two equal triangle here. Here has a two triangle. Okay. AB, this is the C, this is suppose D, this is suppose M, this is M. My dear student, try to understand. Here has two right angle triangle. This is the 90 degree and this is also 90 degree. 90 degree. Okay. If this base AB, then what will be the AD? AD will be L divided 2. AB will be L divided 2. And if this section length is L, then this part, the name, this is dx and name is N. Nm, if the total length is L, and what will be the value of Nm? The value of Nlm will be small l divided 2. So here we can see two right angle. One is CMN and another is CDA. Okay, both the right angle, the angle is same. The angle is theta. Now from triangle CMN, from triangle CNN, we can write this equation, tan theta. We know tan theta is height divided base. Okay, if CMN is a right angle triangle, then this will be the height and this will be the base. So our first duty is to measure the value of base, as the value of this x and total height is L. So the value of this CM will be h minus x. Okay, now we put the value here. Height L divided 2 and base h minus x. Again from triangle CDA, we can write tan theta. Tan theta is equal to height divided base. Height means L divided 2. L divided 2 and base mean h, total h. Total h is the base. If CAD is a right angle triangle, then DC will be the height and this will be the length. Okay, so now because of this right angle triangle, this represent the height and this represent the base. So we can write here. Okay, this is equation 1 and this is equation 2. Okay, now as the angle of the both triangle is same, so we can write here. So we can write L divided 2 divided h minus x is equal to L divided 2 divided h. So we can write here 2 to cancel out. L divided h is equal to h minus x divided h. This is the value. Okay, now we put the value here. 2m divided L divided h, sorry, we take here h and we take here L divided capital L dx. Already we find the value L divided small l divided capital M, h minus x divided h. So we put here the value. So we put here h minus x divided h and dx. So we also write this part by this way. So the value of dm will be 2m divided h square into h minus x dx. Okay, this is the value of mass of very small or slight section. Okay, my dear student, the value will be dm is equal to 2m divided, we write again, h minus x into dx. This is the value of the mass of slight section. Now we apply here the rules. Okay, as this is the very small slight section, the moment of inertia of this small slight section will be very small. How much the moment of inertia will be? This part di is equal to dm into x square. We know from our previous section or previous lecture. Okay, my dear students, now we just put the value di is equal to the value of dm will be 2m divided h square h minus x square dx. Okay, we just rearrange here. At first we put the value dx, then x square will be multiplied. So we write here by rearranging this part x square dx. This is the equation 3. This is the final equation. This equation represents the moment of inertia for this small section. Now our duty is to integrate the both sides. If we integrate the both sides, then we get the total moment of inertia of this triangle. So if we find out the total moment of inertia of this total triangle, then we integrate this equation. After before integrating this equation, we must have to set the limit, in which limit we integrate. Now we discuss. Suppose this is the triangle. If this is the triangle and if this is the height, if this is the height, as this is the rotational axis x prime, when this is the small, very small cross section part, this is the x. When the value of x is equal to 0, that means there is no object here, then moment of inertia will be 0. In case of, if we increase this part length, when the value of x exactly is, then the moment of inertia I will be I. Okay, so within this limit or x is equal to h, the moment of inertia I will be I. Within this limit, in which limit, if we integrate the equation 3 both the side, then we get the total moment of inertia. Now we put the value here. Okay, so integrate di is equal to 2m divided h square h minus x square dx. So our value will be 0 to I and 0 to h. Okay, my dear student, we know integration of di will be I. After integrating, we know third bracket we use 0 to I is equal to 2m divided h square come out from the integration part. Now we integrate this section. Okay, here just try to understand what is actually happened. Here a is square is x square into x cube. Okay, 0 to s. Now we put the upper limit minus lower limit. 2m divided s square. We know this is actually very small formula we apply here. We just increase the power of x by 1 and divide 3 minus power of x will be increased by 1, so this will be 4 and divided 4. After completing the integration, we just use the limit. I think that this small integration all of you know. This is the I is equal to 2m divided s square. Now we put the higher limit here. If we put s replaced by x, then power will be s cube. So we can write here s to the power 4 divided 3. And if we put the value of s, this will be s to the power 4 divided 4. And when we put the lower limit, then both term will be 0. So we can write this part here. Okay, now 2m divided s square. We just take LCM here. Our LCM will be 14. So 4 s power and 3 s to the power 4. Okay, after solving this part, we get our desired equation. 2m divided s square into s to the power 4 divided 12. Now, if we solve this part, then this part will be m s square divided 6. Finally, we get the moment of inertia of the triangle. This is the moment of inertia of the triangle. Okay, my dear student, I think that all of you clearly understand. This equation gives the message: m is the mass of the triangle, s is the height of the triangle, and we just divide by 6. I think that all of you clearly understand. My dear student, before watching this video, you must see my previous lecture, how we can find moment of inertia in case of uniform rod. This is the simple integration. We apply here simple integration. In case of the uniform rod, if the rotational axis passes through the side and passes through the mid side and perpendicular on the length. In this section, in this video, you just at first see the basic concept. Then we just try to solve this advanced level. Okay, I think that this is actually advanced part. Before seeing the small part, small lecture, okay, then you come here, and I think that all of you clearly understand. So before learning, you must have keep in your mind for find out the moment of inertia. Our duty is at first we find out the moment of inertia for very small section. After finding the small section moment of inertia of small section, our challenge is at first we find out the mass of this very small section. Why? Because we use this equation di is equal to dm into x square. Dm represent the very small mass. Okay, that already we indicate in our triangle. This is the cross section, very small area. We take the cross section, very small area, the mass is dm. At first your duty is to find out the value of dm, then put the value here and integrate the both sides, then you get the desired equation. Now we just describe the actually what is happened here. If this is a rotational axis x prime, and if this is a triangle, and if this is the height of the triangle and if this is the base of the triangle, and if this triangle rotate around x prime axis, suppose the mass of the triangle is m. So in this cases the moment of inertia will be I is equal to m s square divided 6. This is the equation. This is not this equation not only valid for the equilateral triangle but also any kind of the triangle. Suppose if the triangle shape is like this, suppose this is the rotational axis and if this is the triangle, then if this is the height of the triangle and if this is the length, okay, or base, if this is the rotational axis, always try to remember that if the rotational axis is x prime which is passing through the base of the triangle, then base cannot be count, okay, as base is the parallel to the rotational axis. For measuring moment of inertia, always we take perpendicular distance, mass and perpendicular distance. So L is directly parallel to the rotational axis, so L cannot count in case of the moment of inertia. So this equation here absent value of L. So in these cases this is also right. Here L is a parallel to the x prime axis, so our duty is to take the perpendicular distance. So here also moment of inertia will be same, m square divided 6. Okay, my dear student, I think that all of you clearly understand. Thanks to all for watching my lecture.